Picture this: thousands of years ago, long before satellites circled the Earth or smartphones lit up our pockets, human beings looked up at the sky and understood something profound. They watched the sun not as a distant ball of fire, but as a living, breathing guide. They saw how its light shifted with the seasons, how its path across the heavens held secrets to survival, spirituality, and the very rhythm of life itself. And with nothing more than careful observation, memory, and sheer ingenuity, they learned to read that silent light like an open book. These women and men, from cultures spread across continents and centuries, achieved something that still inspires awe today. They captured the sun's alignments with near-perfect precision, marking solstices, equinoxes, and celestial events with tools no more complicated than a stick in the ground or a notch on a stone. What's even more remarkable is that they did it all without any of the technology we take for granted: no GPS, no telescopes, not even written numbers in some cases. They used the world around them, the curve of a mountain, the length of a shadow, the alignment of massive stones placed with purpose and meaning. This was a time when knowing the sun's movements wasn't just academic. It meant the difference between feast and famine, between life and death. It shaped ceremonies, guided journeys, and connected communities to the cosmos in ways we can barely grasp today. Yet in our modern world, surrounded by screens and schedules, many of us have lost touch with these natural rhythms. We tell time with digital clocks, navigate with satellites, and rarely pause to notice where the sun rises or sets. That's why this story matters now more than ever. In this video, we're going to journey back through time to uncover how ancient cultures, from the Egyptians along the Nile to the Maya in Mesoamerica, harnessed the power of solar alignments using only their intellect, their environment, and their deep reverence for the sky. We'll explore the methods they developed, the structures they built, and the wisdom they passed down through generations. This isn't just a history lesson. It's an invitation to reconnect with a forgotten art, to see the world through their eyes, and to rediscover what it means to live in harmony with the universe. So come along with us as we step into the silent light of the past, where every shadow tells a story and every sunrise holds a secret waiting to be revealed. Long before written history, humans looked to the heavens not just for wonder but for survival. Their very existence depended on understanding the sun's journey across the sky. They noticed that the world around them changed in a predictable rhythm with the seasons. Animals migrated, plants grew and died, and the weather shifted. The key to navigating this cycle was written in the stars and, most importantly, in the daily path of the sun. Early skywatchers became intimately familiar with their local horizons. They would note that on the longest day of the year, the summer solstice, the sun rose from a specific point, perhaps behind a distinctive mountain peak or a lone, ancient tree. As the year progressed, that rising point would slowly travel along the horizon, moving southward until it reached its extreme position on the shortest day, the winter solstice, before beginning its journey back. This created a reliable, natural calendar etched directly into the landscape. They didn't need sophisticated tools to track this. They used what was already there. A particular arrangement of stones, a carefully chosen notch in a cliff face, or even the shadow cast by a large rock at a certain time of day could serve as a permanent marker. This knowledge was far too vital to be kept by a single person. It was woven into the fabric of the community, passed down through generations in stories, songs, and ceremonies. An elder would point to the horizon and teach the young exactly where to watch for the sun's return after the long, dark winter, a moment of celebration and hope. This practice blended the deeply practical knowing precisely when to plant crops or when to move to a winter camp with a profound cosmic reverence. The sun was not just a ball of fire, it was a life-giver, a deity, a constant in a changing world. This foundational period of human history, built on patient, naked eye observation and a deep connection to the environment, laid the essential groundwork for every sophisticated solar alignment that would follow. It was the first step in a magnificent journey of celestial discovery. Imagine standing on a high ridge at dawn, watching the horizon slowly ignite with the first light of day. For ancient skywatchers, this daily spectacle held far deeper meaning than mere beauty. They noticed something we often overlook today. The sun doesn't rise in the same spot every morning. Throughout the year, its rising and setting points travel along the horizon like a slow-moving pendulum, reaching northern and southern extremes during the solstices before reversing direction. This subtle dance became the foundation of one of humanity's earliest and most widespread timekeeping methods, horizon alignments. Without constructing a single tool, these astute observers transformed their entire landscape into a colossal celestial calendar. A particularly sharp mountain peak, a distinctive notch between two hills, or even a strangely shaped rock formation on the skyline could serve as a critical marker. When the sun's disk appeared to touch or emerge from behind these natural features on specific days, it signaled a turning point in the seasonal cycle. In the American Southwest, various Pueblo cultures still recognize specific horizon points that align with the winter solstice sunrise, an event that traditionally marked the beginning of their ceremonial year and the gradual return of warmth. Similarly, in the British Isles, numerous Neolithic sites appear oriented toward natural features that frame the solstice sun. What's truly remarkable is that this knowledge wasn't recorded in books or carved into tablets. It was preserved through living memory and oral tradition. Elders would take children to specific vantage points season after season, year after year, pointing out the precise location where the sun would rise on the longest day of summer or the shortest day of winter. These lessons were often woven into stories and myths, making the information both memorable and sacred. A tale about a sun god resting on a particular mountain peak during the winter solstice wasn't just entertainment. It was a practical way to encode critical astronomical data for future generations. This intimate familiarity with their environment allowed communities to anticipate seasonal changes with remarkable accuracy, scheduling planting, harvesting, migration, and religious ceremonies in harmony with cosmic rhythms. The entire method relied on patient observation over many lifetimes, building a collective understanding of solar patterns that became embedded in the very identity of a culture. Their landscape was no longer just a place to live. It was a living clock, a sacred map, and a connection to the cosmos itself. While observing the horizon provided a broad calendar, ancient cultures soon developed a more personal and precise tool to measure the sun's daily journey, one that turned the ground beneath their feet into a living map of the sky. This method centered on a remarkably simple yet profound device, the gnomon. At its core, a gnomon is nothing more than a vertical object, like a stick or a pole, planted firmly in the earth. But its shadow, stretching and shrinking across the ground, became one of humanity's first scientific instruments. As the sun arcs across the sky each day, the shadow it casts follows a predictable and beautiful path. At sunrise, the shadow points far to the west, long and thin. Throughout the morning, it shortens and swings northward. At the exact moment of local noon, when the sun reaches its highest point in the sky, the shadow hits its absolute shortest length for that day and points directly north in the northern hemisphere. Then, in the afternoon, the process reverses. the shadow gradually lengthens and sweeps eastward until sunset. This daily dance of light and dark provided a reliable way to mark the hours, turning abstract time into something visible and tangible. The real magic, however, was revealed over the course of a full year. The sun's noontime height changes with the seasons. On the summer solstice, the sun climbs to its highest peak, resulting in the shortest possible noon shadow. Conversely, on the winter solstice, the sun hangs low in the sky, creating the longest noon shadow of the year. By carefully noting the extreme lengths of these shadows, ancient astronomers could pinpoint the solstice dates with incredible accuracy. This wasn't just theoretical. Cultures around the world refined this basic principle into sophisticated technology. In ancient China, for instance, scholars used massive, elaborate gnomons to make astonishingly precise astronomical calculations. They constructed stone pillars several meters tall, and by meticulously measuring the shadow lengths at noon throughout the year, they were able to determine the exact length of the solar year with an error of mere minutes. These instruments were central to creating and maintaining the imperial calendar, which governed agriculture, religious ceremonies, and the emperor's mandate to rule. The Gnomon's influence stretched far beyond timekeeping. The direction of the shadow at noon consistently points true north, providing an ancient compass long before the magnetic needle was invented. This allowed for the accurate orientation of buildings, temples, and entire cities to the cardinal directions, a practice seen in civilizations from Egypt to the Americas. The simplicity of the tool is its greatest strength. You can replicate this ancient experiment in your own backyard. Find a straight stick, place it vertically in a sunny spot, and mark the tip of its shadow at different times throughout the day. You'll see the same arc that countless generations have observed. Mark those same shadow tips over the course of several months, and you will witness the slow, majestic breathing of the seasons, captured in the silent travel of a shadow. This humble method of shadow casting transformed humanity's relationship with the cosmos, providing a direct physical link between the celestial clock in the sky and the human experience on the ground. It was a foundational step that demonstrated how careful observation of simple natural phenomena could unlock profound truths about our universe. Building on the simple principles of shadow casting, ancient cultures embarked on some of humanity's most ambitious and enduring projects, the construction of massive stone monuments precisely engineered to capture the sun's light on the most significant days of the year. This was no longer about marking a spot on the ground. This was about reshaping the landscape itself to serve as a permanent, unshakable connection to the cosmos. The scale of their ambition is staggering. Consider the Great Pyramid of Giza. Its four sides are aligned with the cardinal directions north, south, east, and west, with an error of less than 1/15 of a single degree. To achieve this, Egyptian architects likely used the Gnomon method on a grand scale, patiently tracking the sun's shadows over the course of a year to find true north, and then orchestrating the labor of thousands to orient a mountain of stone with celestial perfection. This alignment wasn't just for show, it was a profound statement, physically anchoring the pharaoh's tomb to the eternal, unchanging order of the heavens. Across the sea in Ireland, the passage tomb of Newgrange offers an even more dramatic example of this architectural precision. Built over 5,000 years ago, this massive earthen mound contains a long, narrow stone passage that leads to a central chamber. For most of the year, this inner sanctum is shrouded in complete darkness, but for a few days around the winter solstice, something miraculous happens. As the sun rises on the shortest day of the year, its beams of light travel directly down the precisely engineered passageway, creeping slowly across the floor until they dramatically illuminate the chamber's intricate spiral carvings for a precious 17 minutes. This event is not a happy accident. The builders designed a special roof box, a carefully constructed opening above the entrance to capture the specific, low-angled light of the solstice sunrise. To achieve this, they needed an incredibly sophisticated understanding of the sun's changing path throughout the year and the engineering prowess to translate that knowledge into stone and earth. The entire structure serves as a powerful metaphor for the sun's victory over darkness, bringing light and warmth back to the world at the depth of winter. These architectural feats were not isolated to one corner of the globe. From the sun temples of Mesopotamia to the intricate observatories of the Maya, we find a recurring theme: cultures investing immense resources to build permanent calendars in stone. The effort required was monumental. Quarrying, transporting, and erecting multi-ton stones without the wheel or metal tools represents a breathtaking communal effort, all directed by a class of priest astronomers who held the sacred knowledge of the skies. The alignments served multiple purposes. On a practical level, they fixed the solar calendar in an immutable form, ensuring that the timing of agricultural cycles and religious festivals would never be lost. On a spiritual level, they created a direct conduit between the human and the divine. In these sacred spaces, the sun itself became an active participant in ritual, its light performing a script written in stone millennia ago. The enduring presence of these structures, still functioning as designed after thousands of years, stands as a permanent testament to the ingenuity, dedication, and cosmic vision of our ancient ancestors. Now, let's shift our focus from the stones and shadows to something even more enduring and intricate: the human mind itself. In countless ancient societies, the most sophisticated astronomical tool wasn't made of rock or wood. It was the living library of cultural memory, carefully preserved and passed down through generations via oral traditions. Without the crutch of written records, these cultures developed incredibly robust systems for memorizing and transmitting complex information. Elders, shamans, and specialized knowledge keepers would dedicate their lives to learning the precise movements of celestial bodies. This wasn't a casual hobby, it was a sacred responsibility. They would commit to memory the exact position on the horizon where the summer solstice sun would rise, the changing length of day throughout the year, and the correlation between specific stars and seasonal events. This vast repository of information was then woven into the very fabric of their culture through songs with specific rhythms and melodies designed to aid recall, through elaborate stories featuring characters that represented celestial bodies, and through ceremonies that physically reenacted the sun's journey. These practices turned abstract data into a lived, experiential knowledge that was inseparable from their identity and survival. A profound example of this exists in the Aboriginal cultures of Australia, where knowledge of the land and the sky is deeply intertwined through the concept of the dreamtime. These are not mere myths or fables, they are intricate maps and calendars encoded in narrative form. Specific dreamtime stories detail the journeys of ancestral beings, and these paths across the landscape correspond directly to the sun's movement throughout the year. A story about an ancestor camping at a particular waterhole might actually be marking the location where the sun sets during the dry season, signaling the best time to find water there. The songlines, a complex network of routes across the continent, are sung narratives that describe landmarks and navigation points, but they also contain astronomical cues. By singing the song of a specific route, a traveler is not only remembering the physical path, but also the position of stars or the sun at different times of year that guide the journey. This oral cartography ensured that vital information for finding food and water sources remained accurate across countless generations. proving that these narratives were functional, scientific databases as much as they were spiritual teachings. The effectiveness of this system relied on a rigorous process of cross-generational verification and repetition. Knowledge wasn't passed down by a single person, it was a communal effort. During ceremonies, multiple elders would recite the same stories and songs, ensuring accuracy through consensus. Younger members of the community learned not through passive listening but through active participation and constant rehearsal, often from early childhood. This created a built-in error correction mechanism. If one person misremembered a detail about a star's position or a seasonal sign, others would correct it, preserving the integrity of the information over centuries. This method was so precise that modern archaeologists and astronomers have been astounded to find that oral traditions describing the position of a star or a solar event thousands of years ago align perfectly with our current astronomical reconstructions of the ancient sky. The endurance of these traditions stands as a powerful testament to the human brain's incredible capacity for storing and transmitting complex knowledge with accuracy, proving that the most advanced technology our ancestors possessed was in many ways the power of their own collective memory and the strength of their spoken word. Now let's journey to the banks of the Nile, where the ancient Egyptians elevated solar observation into a cornerstone of their entire civilization. Their existence was inextricably tied to the sun god Ra and the life-giving rhythms of their river, leading them to develop one of history's most sophisticated and enduring solar-based systems. At the heart of their timekeeping were the magnificent obelisks, towering stone needles that served as monumental gnomons. These were not merely decorative, they were precision instruments on a grand scale. As the sun moved across the sky, the shadow cast by an obelisk would sweep across a paved plaza, often marked with lines or other indicators. Astronomers would carefully monitor this path, using the shadow's length and direction to mark the hours of the day, and more importantly, to pinpoint critical annual events. The most vital of these was the heliacal rising of the star Sirius, which coincided with the annual flooding of the Nile. By combining solar observations with stellar cycles, they could predict the inundation with remarkable accuracy, an event that deposited rich silt onto the farmlands and guaranteed the kingdom's food supply for the coming year. This ability to foresee the flood was so crucial that it formed the very basis of their political and economic stability, making the priests who held this knowledge some of the most powerful figures in the land. This practical need for accurate prediction led directly to the creation of their civil calendar, a revolutionary system that became one of the first to use a 365-day year. They divided this year into 3 seasons, each perfectly aligned with the agricultural cycle of the Nile. Akhit, the time of inundation; Perit, the season of growth when the waters receded and crops were planted; and Shemu, the time of harvest and low water. Each season contained 4 months of 30 days each, with an additional 5 epagomenal days added at the end of the year to complete the cycle. These extra days were considered outside of the normal year, a time of religious ceremony and potential danger. While this calendar drifted by about 1 day every 4 years because it didn't account for the leap year, it was a stunningly accurate achievement for its time and remained in use for thousands of years, influencing later calendars like the Julian and Gregorian systems we use today. The entire structure of their year was a direct reflection of their environment, a solar-driven cycle that governed everything from farming to taxation. The fusion of science and spirituality reached its zenith in the architecture of their temples. The Great Temple Complex of Karnak is a masterclass in celestial alignment. Its main axis was oriented toward the setting sun on the winter solstice, a time associated with the rebirth of Ra. On this significant day, the sun's rays would penetrate deep into the temple's inner sanctum, the Holy of Holies, and illuminate the statue of the god Amun-Ra housed within. This dramatic event was carefully orchestrated. It wasn't just a beam of light but a divine manifestation. It symbolized the pharaoh's role as the intermediary between the gods and the people, receiving the sun's life-giving energy and reaffirming his divine right to rule. This architectural miracle required a profound understanding of astronomy and geometry. The builders had to calculate the precise angle of the sun's descent months or even years in advance, then construct a long, dark corridor of stone that would act as a telescope to capture that single, specific ray of light. The entire ceremony reinforced the cosmic order, or Maat, demonstrating how the sun's predictable journey was intertwined with the stability of the kingdom itself. The Egyptian approach shows us a society where solar observation was not a separate science, but a thread woven into the very fabric of daily life, religion, and power, creating a harmonious system that sustained one of the world's greatest civilizations for millennia. While the Egyptians aligned their monuments with the sun and stars along a mighty river, the Maya achieved a similar feat in the dense jungles of Mesoamerica, developing a system of timekeeping so precise it continues to astonish astronomers today. Their obsession with celestial cycles went far beyond simple agriculture. They believed time itself was sacred, a divine force that moved in repeating, predictable patterns which they were duty-bound to track. This profound cultural priority led to the creation of breathtakingly accurate calendars and some of the most sophisticated observatories of the ancient world, all accomplished without the use of the wheel, metal tools, or pack animals. At the heart of this astronomical pursuit was a deep understanding of the solar year, which they calculated to be 365.2420 days, a figure staggeringly close to our modern calculation of 365.2422 days. This minuscule difference of just 17.28 seconds per year meant their calendar would only drift a single day over the course of 5,000 years. To achieve this level of precision, they needed more than just horizon markers. They needed dedicated structures for continuous, multi-generational observation. The crown jewel of Mayan observational architecture is undoubtedly El Caracol at Chichen Itza. Its name, meaning the snail, comes from the spiral staircase inside its central tower, but its true genius lies in its unique design and precise alignment. Unlike the massive, solid pyramids built for ritual, El Caracol resembles a modern observatory with a circular tower perched on a broad rectangular platform. Its narrow, slit-like windows are not randomly placed. They are carefully engineered to frame specific celestial events, while famously aligned with the extreme rising and setting points of the planet Venus, a body of immense astrological importance to the Maya. These windows also captured key solar events. On the equinoxes, the sun would cast specific light patterns through these openings, and during the solstices, the building's corners aligned perfectly with the sunrise and sunset. The entire structure functioned as a permanent, stone-bodied astronomer, forever locked in a silent dialogue with the heavens. Priests would have climbed the interior staircase to make their observations from a specific vantage point, recording the movements of the sun, moon, and planets against the backdrop of the Yucatan's flat horizon. This long-term, meticulous data collection, likely recorded in bark paper codices, allowed them to refine their calculations over centuries. This observational data fed directly into their complex calendar system, which was actually an interlocking set of multiple calendars. The 260-day sacred round, or Tzolk'in, meshed with the 365-day vague year, or Hub, to create a 52-year calendar round cycle. But their most ambitious temporal project was the long count, a linear calendar that counted the days from a mythological starting point they believed corresponded to August 11th, 3114 BC in our Gregorian calendar. The long count was a masterpiece of mathematics based on a modified base 20 system. They counted time in cycles. 20 days made a uinal, 18 uinals made a ton, 360 days. 20 tons made a kayaton, 7,200 days, and 20 kayatons made a biakton, 144,000 days. This system allowed them to place any date within a vast, continuous timeline stretching for millions of years into the past and future. The fact that they could conceptualize and calculate on such an immense scale speaks to a mathematical sophistication that viewed time as a vast, measurable entity. Their ability to predict solstices, equinoxes, and even solar eclipses with such accuracy was fundamental to their society. It dictated the timing of religious ceremonies that pleased the gods, agricultural cycles that fed the population, and the reigns of kings, whose power was directly tied to their ability to correctly anticipate and interpret celestial phenomena. The Mayan legacy is a powerful testament to what a culture can achieve when it directs its collective intellectual energy toward understanding the cosmos, proving that true precision comes not from advanced technology, but from patient, dedicated observation over generations. Perched high in the mist-shrouded Andes, the Inca city of Machu Picchu stands as a testament to architectural genius, but one stone in particular captures the essence of their celestial wisdom, the Intihuatana. This intricately carved granite pillar, whose name translates poetically to the hitching post of the sun, was far more than a ritual object. It was a precision-engineered astronomical instrument. The Inca, masters of adapting to their dramatic mountainous environment, faced a unique challenge. Unlike cultures on flat plains who could use the distant horizon, their world was a jagged, uneven landscape of peaks and deep valleys. They couldn't simply watch for the sun to rise over a distant mountain. They had to create their own artificial horizon, and the Intihuatana was their solution. The pillar was carved from the very bedrock of the mountain summit, a single piece of stone shaped into a complex, multi-angled form that rose towards the heavens. Each angle and plane of this sacred stone was carefully calculated to interact with the sun's rays at specific times of the year. The most profound moment occurred during the equinoxes. At precisely solar noon on these 2 days, when day and night are of equal length, the sun would be positioned directly overhead. In this perfect alignment, the Intihuatana pillar would cast no shadow at all. For the Inca priests and astronomers, this was a moment of immense spiritual power and cosmic balance. They believed the sun, their supreme deity in Tai, was literally hitched or tied to the earth at this pillar, preventing it from continuing its journey north and disappearing into the sky, which would plunge the world into eternal darkness. This was not a mere superstition. It was a deeply held religious belief that underpinned the stability of their entire empire. By ceremonially securing the sun to its post, the Sapa Inca, who was considered the son of the sun, was fulfilling his most sacred duty, maintaining the cosmic order to ensure the sun would return, crops would grow, and the seasons would continue their cycle. The ritual ensured agricultural fertility and the well-being of the people, directly linking the emperor's power to his ability to commune with the celestial forces. The precision involved in creating the Intihuatana reveals an astonishingly sophisticated understanding of solar geometry. The pillar is not only aligned with the cardinal directions north, south, east, and west, but its 4 corners also correspond to these exact points. This alignment allowed priests to track the sun's progression throughout the year by observing how shadows fell across the stone's different facets and onto the ceremonial platform surrounding it. The slight changes in shadow length and direction from day to day acted as a calendar, marking the approach of solstices, equinoxes, and other significant dates for planting and harvesting in the high-altitude terraces surrounding the city. What makes this achievement even more remarkable is that it was accomplished in one of the most topographically challenging environments on Earth. The builders had to account for the altitude, the specific latitude of the site, and the surrounding obstructing peaks. They transformed these limitations into strengths, using the high vantage point to gain a clearer view of the sky and crafting a tool that turned the mountain itself into a partner in their celestial observations. The Intihuatana is a powerful symbol of Inca innovation, demonstrating how a culture can observe universal celestial patterns and then tailor that knowledge with breathtaking ingenuity to fit the unique demands of their own sacred landscape. What's truly fascinating is how this drive to understand the sun emerged simultaneously across the globe in cultures that had no conceivable way of communicating with one another. The Inca, perfecting their Intihuatana high in the Andes, knew nothing of the Maya astronomers thousands of miles away charting the heavens from the jungles of the Yucatan. The builders of Stonehenge on the Salisbury Plain were utterly unaware of the Chinese scholars meticulously measuring Gnomon shadows to craft their imperial calendar. Yet all arrived at strikingly similar solutions, using upright stones or poles to track shadows, orienting massive architecture to solstice sunrises and sunsets, and weaving these celestial events into the very core of their spiritual and practical lives. This phenomenon, known as independent innovation or parallel development, suggests something profound about humanity itself. When faced with the same undeniable, life-giving force in the sky, different groups of people, using their own unique environments and materials, followed a similar path of inquiry and discovery. It points to a universal human response to the cosmos, a shared cognitive toolkit that drives us to find patterns, seek meaning, and harness the rhythms of nature for our survival and understanding. This isn't to say that all knowledge was developed in complete isolation. In regions connected by land or navigable seas, the exchange of ideas was not only possible but highly probable. The intricate trade networks of the Silk Road didn't just move silk and spices. They were highways for knowledge, where astronomical concepts from Mesopotamia could have slowly filtered eastward, and Chinese innovations could have traveled west. In the Mediterranean, the constant movement of merchants, soldiers, and scholars between Egyptian, Greek, and Roman centers created a fertile ground for the cross-pollination of scientific ideas. The Greek historian Herodotus wrote about the wisdom of Egyptian priests, and it's likely that their advanced understanding of the solar year influenced later Greek and Roman calendar systems. Similarly, across the islands of the Pacific, Polynesian navigators, the greatest open ocean voyagers in human history, shared a sophisticated understanding of star paths and the sun's movement, a knowledge system essential for their incredible migrations and maintained through a strong oral tradition across vast distances. The most tantalizing and debated questions, however, surround the potential for transoceanic contact in the ancient world. Could there have been pre-Columbian voyages that connected the hemispheres? Some researchers point to intriguing architectural similarities, like the use of pyramid structures with temples on top in both Mesoamerica and Egypt, as potential evidence of some form of distant cultural contact, however indirect. Others note the shared emphasis on a 365-day solar calendar. While these parallels are captivating, most archaeologists and historians caution that they are more likely a result of that same universal human ingenuity, solving similar problems with similar materials. Building a stable, monumental structure naturally leads to a wide base and a tapered top, a form we call a pyramid. And observing the sun's cycle will inevitably lead to a calendar that approximates 365 days. The true wonder isn't necessarily that one culture taught another, but that humanity's innate curiosity and intelligence allowed so many different cultures to reach such advanced understandings on their own, creating a beautiful global tapestry of discovery where each thread, though separate, contributes to the same magnificent picture of human achievement. This shared heritage reminds us that our ancestors, no matter where they were from, looked up at the same sun and were moved by the same fundamental desire to comprehend their place in the universe. For these ancient cultures, the sun was never merely a celestial timekeeper or a source of light and warmth. It was a living, breathing deity, a central character in the grand drama of existence. The solstices and equinoxes were not just dates on a calendar but pivotal chapters in this cosmic story, moments of immense spiritual power and transformation. The architecture they built to mark these events served a dual purpose. They were both sophisticated scientific instruments and powerful conduits for religious experience, designed to make the intangible tangible. When the winter solstice sun pierced the inner chamber of Newgrange, it wasn't just a beam of light. It was the breath of life returning to a dormant world, a divine reassurance that the long, cold nights would indeed end. In that precise moment of alignment, the boundary between the human and the divine dissolved, and the entire community could witness and participate in a miracle. This deep spiritual connection is echoed in mythologies across the globe, each culture interpreting these celestial events through its own unique lens. In the cold, dark winters of Scandinavia, the Norse people celebrated Yule, a festival centered on the winter solstice. They believed this period marked the beginning of the end for the long night, a time when the sun god Balder, associated with light and purity, would begin his journey back from the underworld, heralding the return of spring and the eventual victory of light over darkness. Their feasts and rituals were acts of sympathetic magic, encouraging the sun's rebirth. Conversely, in the vibrant tapestry of Hinduism, the sun is personified as Surya, a majestic god riding a chariot drawn by 7 horses, representing the 7 colors of sunlight and the 7 days of the week. Surya is not a distant figure but a daily presence, worshipped as the source of all life, health, and vitality. The practice of Surya Namaskar, the sun salutation, is a physical and spiritual prayer offered at dawn, a direct, embodied engagement with the solar deity that aligns the worshipper's own energy with the cosmic rhythm of the rising sun. The very design of their sacred spaces was a form of prayer written in stone. A temple aligned to the solstice sunrise was more than a building, it was a statement of faith. It declared that the gods were real, their cycles were predictable, and humanity had a designated role within that cosmic order. These events became focal points for entire communities, drawing people together for shared ceremonies that reinforced social bonds and cultural identity. Participating in a solstice celebration at a monumental site was a powerful, multi-sensory experience. The collective anticipation, the hushed silence before the dawn, the eruptive joy as the first ray of light struck the altar. It transformed abstract belief into a communal, unforgettable event, forging a shared memory that strengthened the collective identity of everyone present. This fusion of precise astronomical observation with profound spiritual meaning created a holistic world, where science and religion were not opposing forces but 2 sides of the same coin, both seeking to understand humanity's place within a vast, ordered, and meaningful universe. When we look at the grandeur of a pyramid or the perfect circle of Stonehenge, it's tempting to assume our ancestors possessed some lost, advanced technology. The truth, however, is far more fascinating. Their secret weapon wasn't magic or alien intervention. It was a profound mastery of simple, practical mathematics, applied with painstaking patience and ingenuity. Without the formal theorems of Euclid or the trigonometric functions we learn in school, they discovered and harnessed fundamental geometric truths through direct, hands-on experimentation with the world around them. The most powerful tool in their mathematical toolkit was likely the humble rope. By stretching a cord between two fixed points, they could create a perfectly straight line, the foundation of all their alignments. To create a perfect right angle essential for orienting structures to the cardinal directions, they employed a simple but brilliant rope and peg method. They would drive a peg into the ground and tie a long rope to it. Then, holding the rope taut, a second person would walk in a wide arc, scratching a giant circle into the earth. By choosing a point on that circle and using a rope of a specific length to connect it to the original peg and another point on the circumference, they could form a perfect 3-4-5 triangle, guaranteeing a right angle at the central peg. This practical application of what we now call the Pythagorean theorem was almost certainly used to lay out the impeccably square bases of the Egyptian pyramids. Their understanding of angles extended far beyond the right angle. To bisect an angle, for instance, to find true north by splitting the angle between the rising and setting points of a star, they used another elegant rope technique. They would trace the angle on the ground and then, from its vertex, use a fixed length of rope to mark equal distances along each leg. Using a longer rope, they would then find the point that was equidistant from these two marks. A line drawn from the vertex to this point would perfectly split the angle in half. This method allowed them to determine the meridian, the north-south line in the sky, with astonishing accuracy. They also grasped the concept of circles and their properties intuitively. The builders of Stonehenge, for example, likely used a central post and a long rope to scribe the massive concentric circles of bluestones and sarsen, ensuring their perfect form. This geometric knowledge wasn't written down in textbooks. It was a living, practical craft passed from master builders to apprentices, a tradition of rope stretchers who literally measured the world. This geometric genius was perfectly complemented by sophisticated numerical systems tailored to their astronomical needs. The Maya, for instance, developed a base 20 or vigesimal numeral system, which is believed to be rooted in the total number of human fingers and toes. This system was far more than a counting method. It was the engine behind their incredibly precise calendar calculations. Using a placeholder for zero, a conceptual leap that eluded many other ancient civilizations, they could perform complex place-value arithmetic. Their long-count calendar required them to manage enormous units of time, like the Biakton, which represented 144,000 days. Manipulating these vast numbers to predict solar years, lunar cycles, and the synodic period of Venus with minute accuracy would have been impossible without their advanced mathematical framework. They weren't just counting days, they were modeling cosmic cycles through numbers, using their vigesimal system to compute the intricate dance of the heavens with a precision that still commands respect from modern astronomers. This beautiful fusion of simple, hands-on geometry and complex, abstract numeracy demonstrates that their true technology was not made of metal and microchips, but of intellect, observation, and an unwavering determination to measure the cosmos. This pursuit of celestial precision was never a one-and-done endeavor. It was a grand, multi-generational project of trial and error, a slow, meticulous refinement of knowledge that unfolded over centuries. Unlike modern science, which can rapidly test and adjust hypotheses in a lab, ancient astronomy operated on a timescale that is almost unimaginable to us today. An initial alignment marker, a single standing stone, or a notch carved into a cliff might be placed based on the observations of a single lifetime, but that was just the first draft. The true test came over the decades that followed, as successive generations of skywatchers would monitor the sun's path against that marker. They might notice that on the summer solstice, the first sliver of the sun appeared just a finger's width to the left of the stone, or that a shadow fell a handspan short of its intended target. These tiny discrepancies were not failures, they were invaluable data points. This process of iterative learning is beautifully illustrated at a site like Nabta Playa in the Sahara Desert. What began as a simple calendar circle around 6,500 BCE, likely used by cattle herders to track the rainy season, evolved over millennia. Archaeologists have found that the stones were not simply placed and forgotten. Instead, they were deliberately moved and adjusted over hundreds of years. As the community's understanding of the solar cycle deepened and their observational techniques became more sophisticated, they fine-tuned the positions of these megaliths to achieve a more and more precise alignment with the solstice sunrise. This wasn't a project for a single chief or priest. It was a sustained cultural commitment, a promise made by one generation to the next to keep watching, keep learning, and keep correcting. The knowledge of what to adjust and why was stored not in books, but in the living memory of the community, passed down through stories, ceremonies, and the direct apprenticeship of young observers by their elders. This patient, long-term perspective stands in stark contrast to our modern desire for instant results and quick fixes. For these ancient astronomers, a miscalculation wasn't a disaster to be swept under the rug. It was a puzzle to be solved by their grandchildren or great-grandchildren. They understood that the cosmos operated on a vast, slow timetable, and to understand it, they had to match its rhythm with their own persistent curiosity. This approach required a profound humility and a deep trust in the cumulative power of shared knowledge. A single human life was merely one data point in a continuous, centuries-long experiment. The breathtaking accuracy we see in fully developed sites like Stonehenge or the Karnak Temple is not the product of a sudden flash of genius, but the end result of this painstaking process of observation, adjustment, and refinement. It is a powerful testament to what humanity can achieve when we think not in terms of years, but in terms of generations, proving that true precision is often born not from speed, but from steadfast, patient diligence. Human ingenuity truly shines when we see how cultures didn't just apply a one-size-fits-all approach to solar observation, but instead masterfully adapted their methods to the unique challenges and opportunities of their local environments. In the stark, dramatic landscapes above the Arctic Circle, the rules of the game were completely different. Here, the sun doesn't simply rise and set each day for much of the year. During the summer months, it performs a continuous, lazy circle in the sky, never actually dipping below the horizon. This phenomenon, known as the midnight sun, meant that traditional horizon-based markers for sunrise and sunset were useless. Instead, Arctic peoples like the Inuit and the Sami developed a profound understanding of the sun's constant, low arc across the heavens. They learned to tell time and navigate by the sun's position relative to distinctive ice formations, pressure ridges, or coastal landmarks, even when it was shining at 2 in the morning. Conversely, during the long polar night, they relied on the brief twilight glow of the low-hanging winter sun or the brilliant light of the moon reflecting off the endless snow to orient themselves and track the passage of time until the sun's triumphant return. On the opposite end of the environmental spectrum, in the world's vast and open deserts, ancient peoples were gifted with an astronomer's dream, perpetually clear, unobstructed skies. The flat, expansive horizons of places like the Sahara or the Arabian Desert provided a perfect, blank canvas for tracking the sun's precise journey. The intense clarity of the air allowed for incredibly sharp observations of the sun's disk as it appeared to touch the distant Earth. Cultures in these regions didn't need to construct tall markers. The horizon itself was their instrument. They could use any distant, stable landmarker, a solitary mountain, a specific dune, or a peculiar rock outcrop as a fixed point of reference. The Nabateans, who built the magnificent city of Petra, likely used such desert horizons to calibrate their own sophisticated water management and agricultural calendar, aligning their carved temples and tombs with solar events to spiritually anchor their oasis civilization in the harsh desert. Dense, closed canopy rainforests presented yet another set of challenges. In the lush jungles of Mesoamerica and Southeast Asia, a thick roof of leaves often blocked a clear view of the sky. Here, cultures couldn't rely on a distant horizon. They had to create their own. The Maya, for instance, would carefully manage their environment, creating artificial clearings or maintaining specific sacred groves where key trees acted as living markers. A particular kapok tree, for example, might be known as the place where the sun rose directly behind its trunk on the spring equinox, signaling the time to begin planting maize. In other forested regions, notches were cut into the canopy to create a narrow window through which to observe the sun's passage, or wooden posts were erected in clearings to cast shadows on marked ground. This demonstrates a beautiful reciprocity with their environment rather than conquering the forest. They worked with it, integrating natural features into their celestial calendar and showcasing a flexible, pragmatic approach to reading the silent light that filtered down through the leaves. Even the most perfectly engineered solar alignment is not set in stone forever when viewed against the vast canvas of geological time. The Earth itself is a dynamic, shifting stage, and over the centuries and millennia, the celestial ballet our ancestors so carefully observed would have slowly, imperceptibly changed its choreography. One of the most significant forces altering this cosmic dance is a phenomenon known as the precession of the equinoxes. Imagine a spinning top just as it begins to slow down. Its axis starts to wobble in a slow, wide circle. Earth does the very same thing. Our planet's axis completes one full wobble or precessional cycle, approximately every 26,000 years. This means that the North Star, Polaris, which today sits almost directly above our North Pole, was not always our guiding light. Thousands of years ago, the star Thuban in the constellation Draco held that position, and in thousands of years to come, it will be the brilliant star Vega. This gradual shift means that the position of the Sun against the backdrop of stars on any given equinox or solstice slowly drifts over centuries. An alignment that was perfect for a solstice sunrise in 3000 BC would be noticeably off by just a few hundred years and completely askew today. This presents a fascinating question. Did ancient astronomers detect this incredibly slow drift? While they wouldn't have understood the astrophysics behind precession, they were meticulous observers. A priest at a temple like Karnak, inheriting knowledge passed down for generations, might have noticed that the sacred beam of light on the winter solstice was striking the inner sanctum's altar a little later each year, or was no longer perfectly centered. There is compelling archaeological evidence that suggests they didn't just notice, they acted. At some ancient sites, we find evidence of rebuilding or realignment. A stone might have been slightly moved, or an entire doorway widened over generations to compensate for the sun's shifting path. This indicates a long-term, institutional awareness of these subtle changes and a cultural commitment to maintaining the sacred precision of their celestial instruments. It shows they understood that their relationship with the cosmos was not static, but required active stewardship and occasional correction, a testament to their deep, multi-generational thinking. Beyond the slow wobble of the axis, more immediate geological and climate events could also disrupt alignments. Earthquakes could tilt massive stones by just a fraction of a degree, enough to throw a precise alignment off for 1,000 years. Changes in sea level or the silting of a river delta could alter the visible horizon from an observatory. Even something as gradual as the erosion of a specific mountain peak used as a horizon marker could, over centuries, change the entire meaning of a sightline. Furthermore, significant shifts in climate, such as the transition from a wetter to a drier period, could have forced a community to migrate, abandoning their carefully aligned structures to the elements. For archaeologists, these very imperfections and shifts are now valuable clues. By calculating how much an alignment is off and comparing that to the known rate of precession or the history of seismic activity in the region, they can often work backwards to pinpoint the exact era when the structure was first built and aligned, effectively using the sky as a calibration tool for dating these ancient marvels. This resilience in the face of a changing world underscores a fundamental aspect of these cultures. Their connection to the natural world was not one of rigid control, but of adaptive observation. They built not for a single moment in time, but for a continuous, evolving conversation with the cosmos, demonstrating a flexibility and awareness that is as impressive as their initial astronomical achievements. The construction of a solar-aligned monument was far more than an architectural project. It was a profound act of social engineering that mobilized entire societies toward a common, celestial goal. Envision the scene at a place like Stonehenge during its peak construction phase. Not a silent, empty plain, but a bustling hub of coordinated activity. Hundreds, perhaps even thousands of people would have been engaged in the immense task, quarrying the massive sarsen stones from sites miles away, shaping them with nothing but stone hammers and antler picks, and then transporting these multi-ton giants using log rollers, ropes, and sheer human muscle required an astonishing level of organization. This was not slave labor driven by a whip, as outdated theories once suggested, but a communal effort likely fueled by shared belief, social obligation, and the promise of spiritual reward. The entire operation would have required managers, engineers, logisticians, and laborers, a temporary but highly structured society united in its purpose. At the helm of these colossal endeavors were the specialized knowledge holders, the priest astronomers, the chief engineers, the wise elders. These individuals were the guardians of the sacred celestial secrets. They possessed the multi-generational knowledge of the sun's precise path, the mathematical understanding of geometry and alignment, and the engineering prowess to translate that knowledge into stone. Their authority did not come from physical force, but from their exclusive command of this critical information. They were the ones who could predict the solstice, who knew exactly where to place the first stone, and who could direct the workforce to achieve a vision that would take decades, sometimes centuries, to complete. This centralization of esoteric knowledge naturally intertwined with political and religious power. The leader who could command the sun to align with his temple, or who could accurately predict the changing seasons, held immense sway over the population, legitimizing their rule through a demonstrated connection to the divine order of the cosmos. Beyond the practical achievement, these projects served a deeper social function. The very act of working together on a task of such scale and duration forged powerful bonds within the community. It created a shared identity and a collective pride in creating something that would endure for millennia. This sense of common purpose was then celebrated and reinforced during the solar events themselves. The winter solstice sunrise at Newgrange or the summer solstice at Stonehenge likely became major communal festivals. People would travel from distant villages to gather at these sacred sites, participating in rituals, feasts, and ceremonies that marked the turning of the year. These gatherings were not passive spectacles, they were active participatory events that strengthened cultural unity, transmitted shared values to the young, and reminded everyone of their place within a larger cosmic story. The monument itself became a permanent anchor for that shared identity, a symbol of what the community could achieve when united by a common vision. This intricate dance of labor, knowledge, and celebration reveals that for ancient cultures, understanding the sun was never a solitary pursuit. It was the very glue that held society together, blending the practical, the political, and the spiritual into a single, harmonious endeavor. It's a humbling thought, really. While we today have the immense power of orbiting satellites, powerful computers, and telescopes that can peer to the edge of the observable universe, our ancient ancestors achieved a level of precision that still commands respect with nothing more than their eyes, their patience, and their profound connection to the world around them. The Mayas' calculation of the solar year, for instance, came within mere minutes of our modern measurement of 365.2422 days. They did this without calculators, without laser rangefinders, and without any understanding of gravitational physics. Their tools were sticks, stones, and the unwavering discipline of recording the sky's motions generation after generation. This isn't just a quaint historical footnote. It's a stunning testament to the power of dedicated, long-term human observation. Modern technology, of course, offers us unparalleled convenience and a degree of precision that would have been unimaginable to a Mayan priest. A farmer today can check a weather app on his phone to know the exact forecast, and a sailor can navigate the open ocean with a pocket-sized device that talks to satellites in space. We can predict solar eclipses down to the second, centuries in advance, but this incredible convenience comes with a subtle cost, a growing disconnect from the natural world and its rhythms. We no longer need to look up to know what time it is or what season we're in. We simply glance at a screen. This disconnection can sometimes make us passive observers of the cosmos, rather than active participants in its cycles. The intimate, lived experience of watching the sunset point creep along the horizon day by day, or feeling the sun's warmth diminish as winter approaches, is a form of knowledge that can't be downloaded from a server. Yet, a fascinating movement is growing among modern enthusiasts who are deliberately choosing to step away from their screens to reconnect with this older way of knowing. Amateur astronomers, history buffs, and even school groups are reviving these ancient techniques, not out of necessity, but for the sheer joy and profound satisfaction of the hands-on experience. They go out into fields with nothing but a simple gnomon, carefully marking the tip of its shadow throughout the day and over the course of a year. They visit Neolithic sites on the solstices to witness the alignments for themselves, feeling the same awe as the sun's rays pierce a dark chamber exactly as designed. This isn't a rejection of modern science, it's a complementary practice. It's about reclaiming that personal, visceral connection to the cosmos, understanding the principles behind our calendars and clocks by physically engaging with them. It reminds us that astronomy isn't just a subject in a textbook, it's a living, breathing interaction between ourselves and the universe. This comparison between the ancient and the modern ultimately reveals a complex story of both incredible advancement and a certain kind of loss. We have gained a God's eye view of the universe, but we may have lost a little of the earth-bound wonder that comes from personally tracking the sun's silent journey. The story isn't about choosing one over the other. It's about recognizing the value in both. The meticulous data from our satellites helps us understand the grand mechanics of the solar system, while the simple act of observing a sunset can ground us in our place within it. This balanced perspective allows us to appreciate the genius of our ancestors not as primitive, but as profoundly sophisticated in their own right, having mastered the art of reading the sky with the most advanced tool of all, their own attentive, unaided humanity. For centuries, the true genius behind many ancient solar alignments lay hidden in plain sight, their secrets buried not under sand, but under layers of forgotten knowledge and shifting cultural priorities. These celestial calendars in stone were often mislabeled by early explorers as primitive temples or vague ceremonial sites, their astronomical purpose completely overlooked. The turning point in this story of rediscovery came with the marriage of two powerful forces: advanced technology and a newfound respect for indigenous wisdom. Modern archaeologists, armed with tools like theodolites for precise angle measurement and LiDAR for seeing through dense jungle canopy, began to re-examine these sites with fresh eyes. But perhaps the most revolutionary tool has been computer simulation, allowing researchers to digitally rewind the sky thousands of years and project the sun's path onto a virtual model of any ancient structure. This process has repeatedly revealed intentional alignments that are impossible to dismiss as coincidence. A profound example of this technological and cultural detective work unfolded at Choco Canyon in New Mexico. For generations, the monumental great houses and enigmatic kivas of the ancestral Puebloan people were studied primarily for their architecture and artifacts. Then, in the late 20th century, researchers like Anna Sofer began meticulously surveying the site, armed with theodolites and a hunch. Their measurements revealed something extraordinary. The walls of the great house of Casa Rinconada were aligned to within a fraction of a degree to the cardinal directions. Furthermore, a specific window and doorway combination was found to perfectly frame the rising sun on the summer solstice. But the most stunning find was the sun dagger on Fajada Butte. Here, 3 large stone slabs were positioned so that daggers of sunlight would slice between them, bisecting a spiral petroglyph at exactly noon on the summer solstice and framing it perfectly during the winter solstice. This was not a crude marker, it was a complex and precise solar calendar engineered with breathtaking skill. For the Pueblo people, these scientific discoveries were not revelations but validations. Their oral histories had always spoken of their ancestors' deep connection to the sun and stars, but this knowledge was often marginalized or dismissed by early academic circles as myth or folklore. The archaeological proof that Choco's buildings were deliberately aligned with celestial events forced a dramatic and long overdue shift in perspective. It demonstrated that the oral traditions were not merely symbolic stories but accurate, preserved records of sophisticated astronomical science. This has led to a much richer and more collaborative approach to archaeology, where scientists now actively seek out and work with indigenous knowledge keepers. The conversation is no longer one-sided. It is a true dialogue where an elder's story about a solstice ceremony can provide the crucial clue that guides where to point the theodolite. This partnership is healing historical rifts and creating a more complete and respectful understanding of the past. This process of rediscovery is far from over, it is accelerating. Ground-penetrating radar uncovers buried post holes that hint at long-vanished wooden observation structures. Drone photography provides a bird's-eye view, revealing large-scale alignments across entire landscapes that are invisible from the ground. Each new technological leap offers another chance to listen more closely to the silent stones. With every solstice, teams of researchers and community members gather at sites around the world, watching and waiting to see if a new theory holds true, to see if the sun will indeed strike that specific carving or illuminate that dark passageway as predicted. It is a powerful, living science that connects us directly to the minds of the ancient astronomers. This ongoing conversation between the cutting edge of modern technology and the enduring wisdom of the past doesn't just uncover facts. It deepens our awe for the universal human impulse to find order and meaning in the grand clockwork of the heavens. The best part about these ancient techniques is that they are not locked away in history books or reserved for experts with expensive equipment. They are available to every single one of us, right here and now, using the most basic tools imaginable. To truly understand the awe our ancestors must have felt, you can begin with a simple experiment in your own backyard. Find a straight stick about 3 feet long and plant it firmly in a sunny, open spot where it won't be disturbed. This is your personal gnomon, your connection to millennia of celestial observation. Each day, at the exact same time, solar noon is best, which you can find using a reliable clock app that accounts for your time zone. Go outside and mark the very tip of the stick's shadow with a small stone or a dab of paint. Do this for several weeks, and you will witness a story unfold right at your feet. You'll see the shadow's path slowly curve and its length change. In the weeks leading up to the summer solstice, the noon shadow will get a little shorter each day. Then, after the solstice, it will begin to slowly stretch out again as the sun's arc across the sky lowers toward winter. This daily ritual transforms an abstract astronomical concept into a tangible, personal experience, a quiet moment of connection with the fundamental rhythm of our planet. For those seeking a more communal and powerful experience, numerous heritage sites around the world open their doors for special events during the solstices and equinoxes. While you might not be able to walk among the stones at Stonehenge during the summer solstice without special access, you can join the thousands of people who gather just outside the perimeter to witness the sunrise perfectly align with the heel stone, a moment met with cheers and celebration. At Machu Picchu, though the Intihuatana itself is now roped off to protect it, simply being present in the city on the winter solstice and feeling the sun's intense energy at that high altitude is a profoundly moving experience. Closer to home, many smaller archaeological sites, from Native American petroglyph sites in the American Southwest to reconstructed Celtic ring forts in Europe, host guided gatherings where park rangers or local experts explain the alignments and the cultures that built them. These events are more than just tourist attractions. They are living ceremonies that keep ancient traditions alive, allowing people from all walks of life to collectively witness the same celestial events that have inspired humanity for thousands of years. This hands-on approach has also become a powerful tool for education, bringing the science of astronomy down to earth in a way that textbooks never could. School teachers across the globe are incorporating these simple methods into their curricula, having students build their own miniature Stonehenges out of cardboard or track the sun's path with homemade sundials. These projects teach children not only about the Earth's tilt and orbit, but also about geometry, history, and the scientific method of observation and recording. Local astronomy clubs and hobbyist groups often organize solstice watch parties or equinox hikes, leading people to natural vantage points to observe the sun setting or rising along the horizon just as ancient peoples did. This fusion of science, history, and outdoor activity creates a multi-layered learning experience that is both engaging and unforgettable. It demonstrates that science isn't just something that happens in a sterile lab. It is a dynamic process of inquiry that began with our earliest ancestors looking up at the sky in wonder. Ultimately, engaging with these practices offers a much-needed antidote to the fast-paced, digitally saturated modern world. It encourages a slower, more mindful pace, attuning us to the natural rhythms that govern all life on Earth. Checking the length of your backyard stick's shadow becomes a daily meditation, a moment to step away from screens and simply notice the world. planning a trip to a solstice event gives us something to look forward to that is tied to the natural cycle of the seasons, not the commercial calendar. This reconnection fosters a deep sense of gratitude for the ingenuity of those who came before us and a renewed appreciation for the stunning precision of our universe. It transforms solar observation from a dusty academic subject into a vibrant, living tradition, a timeless conversation between humanity and the heavens that we are all invited to join. This personal engagement naturally leads us to a vital question as we rediscover and embrace these ancient sites for our own enrichment. What is our responsibility in ensuring they are protected for the generations of curious minds yet to come? These ancient observatories, carved by time and human ingenuity, now face a new set of challenges that threaten their very existence and the precise alignments they were built to preserve. The very wonder they inspire has become a double-edged sword, as millions of visitors each year, while bringing economic benefit, also bring the gradual wear of countless footsteps, the corrosive effects of increased humidity from human breath, and the unintended consequences of even the most gentle touch. The stones of Stonehenge, for instance, have suffered more erosion from 20th and 21st century tourists than in the previous 3,000 years combined. Beyond the pressure of tourism, the overarching specter of climate change presents an even more insidious threat. Rising sea levels endanger coastal sites, while increased frequency of extreme weather events, more intense rainfall, stronger winds, and wider temperature fluctuations can destabilize ancient masonry, erode delicate carvings, and even alter the surrounding landscape in ways that could throw off the sightlines critical to their celestial function. In response to these pressing dangers, a global effort has emerged, led by organizations like UNESCO, which works to designate and protect these places as World Heritage Sites. This isn't merely about putting a plaque on a wall. It involves creating comprehensive management plans that balance the complex needs of preservation with the public's desire for access. This can mean implementing innovative solutions like limiting daily visitor numbers, constructing viewing platforms that keep people at a respectful distance, or even closing sensitive areas to all but scholarly research. Crucially, modern preservation philosophy has shifted dramatically. It no longer centers on a top-down approach where outside experts dictate terms. The most successful projects now involve deep, ongoing collaboration with the local and indigenous communities for whom these sites are not relics of a dead past, but living, breathing cornerstones of their cultural and spiritual identity. This collaborative model represents the heart of ethical archaeology today. It means that before any conservation work begins, before a single stone is stabilized or a path is rerouted, archaeologists and preservationists sit down with tribal elders, community leaders, and cultural knowledge keepers. The goal is to listen and learn. A scientific team might want to reinforce a wall with the most durable modern material, but if that material is culturally prohibited or aesthetically jarring to the community that holds the site sacred, a different solution must be found together. Interpretive signs and museum exhibits are no longer written solely by academics. They are co-authored, ensuring the stories told are not just archaeologically accurate, but also culturally authentic, honoring the traditions and oral histories that have kept the meaning of these places alive for millennia. This respectful balance between access and preservation is a delicate dance. Complete closure might protect a site physically, but kills its cultural vitality and denies people the transformative experience of witnessing a solstice alignment firsthand. Conversely, unfettered access loves a site to death. The answer lies in managed, mindful accessibility. This can take the form of virtual reality tours that allow anyone in the world to explore a fragile site without causing harm, or of special guided events led by members of the descendant communities themselves. who can share the significance of the place from a deeply personal perspective. By treating these monuments not as static ruins to be gawked at, but as active, sacred heritage to be stewarded, we accept a profound responsibility. We become temporary guardians, entrusted with safeguarding this irreplaceable dialogue between humanity and the heavens for the countless generations yet to come, ensuring the silent light continues to speak its ancient truths. There's a profound lesson etched into these ancient stones, one that speaks directly to the most pressing challenge of our modern era. The mastery our ancestors demonstrated in tracking the sun emerged from a fundamental philosophy of working in concert with nature, not conquering it. Their entire approach was rooted in sustainability long before the term ever entered our lexicon. Consider their materials: the standing stones of Kalanish, the great pyramids of Giza, the intricate structures of Machu Picchu. All were crafted from what the local environment provided. They didn't manufacture synthetic composites or import materials from across oceans. They used stone, earth, wood, and bone, materials that would eventually return to the earth without leaving a toxic legacy. This stands in stark contrast to our current paradigm, where we often exploit resources with little regard for long-term consequences, creating energy systems that extract without replenishing and generate waste that persists for millennia. This ancient wisdom finds powerful application in the growing field of passive solar design, an architectural philosophy that directly echoes the principles of the Maya and the Egyptians. Modern architects are now looking to these old masters for inspiration, designing buildings that harness the sun's energy through strategic orientation, thermal mass, and natural ventilation, just as the ancients aligned their structures to capture the sun's warmth in winter and avoid its heat in summer. A well-designed passive solar home needs no complex mechanical systems to remain comfortable. Its very shape and position do the work, dramatically reducing energy consumption. This isn't high-tech, it's smart tech, applying an ancient understanding of solar paths to modern living. It's a perfect example of how advanced knowledge doesn't have to mean complex domination of our environment, but can instead be a graceful and efficient dance with natural forces. The most crucial takeaway from these ancient astronomers is their long-term perspective. They planned and built for cycles that extended far beyond their own lifespans, investing immense effort into projects whose full value would only be realized by their grandchildren's grandchildren. They understood that they were part of a continuum, stewards of knowledge and builders of a legacy meant to endure. This intergenerational thinking is perhaps the most vital lesson we can learn. Our modern economies often operate on short-term cycles of quarterly reports and election terms, incentivizing decisions that yield immediate benefit at the expense of long-term stability. The ancients remind us that true sustainability requires a vision that spans centuries, not just seasons. They planned for the great year, the slow procession of the equinoxes, accepting that some patterns are too vast to be fully comprehended in a single lifetime, but are nonetheless essential to respect. This holistic view integrated every aspect of life into a coherent whole. For them, astronomy wasn't separate from agriculture, religion from science, or architecture from ecology. It was all part of a single, interconnected system. The sun's path dictated when to plant, which in turn dictated when to hold ceremonies, which reinforced social bonds and cultural identity. This integrated existence fostered a deep reverence for the natural world, because every part of life was visibly and undeniably dependent on its cycles. Our modern world, for all its comforts, has fragmented this wholeness. We live in compartments, often disconnected from the sources of our food, water, and energy. We're learning this ancient art of connection, seeing our homes, our food systems, and our energy use as part of a larger ecological whole, is the first step toward building a future that is not just technologically advanced, but also wise, resilient, and truly in harmony with the planet we call home. The ancient human drive to connect with the sun's journey has not been lost to history. It has been reborn, finding vibrant new expression in the realm of contemporary art and global culture. Modern creators are reaching back through time, drawing inspiration from those same celestial patterns that captivated our ancestors, but they are translating this ancient vocabulary into a stunning new language of light, space, and collective experience. Artists like James Turrell have essentially become modern-day architect astronomers, constructing what he calls sky spaces, are specifically designed chambers with a precise aperture open to the sky. Inside one of these spaces, visitors don't just look at the sky, they experience it as a living canvas. As the sun moves across the opening, the color of the sky itself appears to shift and intensify, transforming from a soft dawn pink to a profound deep blue, and finally to the velvety black of night punctuated by stars. These are not merely art installations, they are secular temples, modern-day equivalents of Newgrange or the Intihuatana, engineered to frame a celestial event and provoke a profound sense of wonder, reminding us of our small but significant place within the vast cosmos. This artistic fascination with celestial light extends far beyond gallery walls and into the stories we tell ourselves on screen. Filmmakers and writers frequently use solar alignments as powerful metaphors for destiny, revelation, and the invisible threads connecting humanity across time. A character might discover a hidden truth at the precise moment of a solstice sunrise, or a story's climax might coincide with an eclipse, symbolizing a dramatic turning point or a convergence of fates. These narratives tap into a deep, almost primal understanding that these moments are special, that they hold a weight and a meaning that transcends the ordinary passage of time. They are a cultural echo of the belief that the cosmos is not indifferent to our lives, but is instead a participant in our story, just as we are participants in its grand, cyclical performance. Perhaps the most powerful testament to the enduring power of solar rhythms is their continued role at the heart of living, breathing community celebrations all over the world. These are not historical reenactments but vibrant, evolving traditions that thousands of people eagerly participate in every year. In Sweden, the Midsummer Festival is a beloved national holiday, a joyous celebration of the summer solstice where communities gather to raise and dance around a maypole decorated with flowers, feasting on herring and new potatoes under a sun that barely sets. The celebration is a direct, unabashed embrace of light and life at its peak. Similarly, in places like Stonehenge and countless other ancient sites, neo-pagan and druidic groups gather for the solstices and equinoxes, not as tourists, but as spiritual practitioners honoring the old ways in a modern context. They sing, chant, and meditate as the sun aligns with the ancient stones, creating a powerful bridge between the deep past and the present, proving that the desire to mark these celestial turning points with reverence and community is as strong today as it was 5,000 years ago. This widespread cultural revival does something truly remarkable. It keeps ancient wisdom alive not as a dusty artifact in a museum, but as a living, adaptable practice. It demonstrates that we don't have to choose between our hyper-connected digital world and a meaningful connection to natural cycles. We can have both. A person might use a sophisticated app to get the exact minute of sunrise, then go outside to witness it with their own eyes, feeling the same awe that an Egyptian priest or a Mayan astronomer must have felt. This blending of the old and the new creates a rich, multi-layered understanding of our place in time. It shows us that our fascination with the sun is not a relic of a primitive past but a timeless, enduring part of the human experience, a constant thread woven through the tapestry of our art, our stories, and our communal gatherings, forever pulling our gaze upward to the silent, magnificent light. It's a captivating idea, isn't it? The notion that the breathtaking precision of ancient solar alignments must be the work of visitors from another star, or a long-vanished super-civilization wielding technologies beyond our comprehension. This narrative, popularized by countless documentaries and books, offers a seductively simple answer to a complex question, but in doing so, it commits a profound disservice to the very people whose achievements we claim to marvel at. This perspective, often called paleo-contact or ancient astronaut theory, doesn't actually solve a mystery. It creates one by refusing to accept the overwhelming evidence of human capability, patience, and genius that is written into the archaeological record. When we look at a site like the Great Pyramid, the theory of alien intervention asks us to ignore the nearby quarries where the stones were cut, the worker villages that housed the thousands of laborers, and the ramps and tools discovered by archaeologists that explain the construction methods. It asks us to disregard the clear evidence of gradual development. We don't see perfect astronomical alignments appear out of nowhere. We see a fascinating evolution. Before the pyramids, the Egyptians built mastabas. Before Stonehenge's giant sarsens were erected, the site featured simpler wooden structures and earlier arrangements of smaller bluestones that were adjusted over centuries. This is not the story of a sudden gift of advanced knowledge. It is the story of a slow, deliberate, multi-generational process of experimentation, observation, and refinement. It is a story of trial and error where initial attempts were sometimes slightly off and later generations, building on that accumulated knowledge, corrected and improved them. This evidence of gradual learning is the most powerful argument against the myth of external intervention. It shows a human journey with all its struggles and triumphs intact. Another common source of misinterpretation comes from projecting our own modern, hyper-rational worldview onto ancient cultures. We see a structure aligned with the solstice, and our first instinct is to label it an observatory or a calendar. While these sites certainly served those practical functions, this interpretation often misses their deepest purpose. For the people who built them, the winter solstice wasn't just the shortest day of the year. It was a moment of profound spiritual terror and hope, a battle between light and darkness where the very survival of the world was at stake. The alignment was not a cold, scientific calculation. It was a ritual act, a form of sympathetic magic designed to ensure the sun's return. By physically capturing that first ray of light in a dark chamber, they were participating in the cosmic drama, helping to bind the sun to the earth and guarantee the continuation of life. To reduce these profound spiritual acts to mere timekeeping is to strip them of their cultural and emotional power. It's like calling Notre Dame Cathedral a very elaborate town hall because people sometimes met there. Ultimately, the ancient aliens narrative is a form of intellectual colonialism. It subtly implies that indigenous and ancient non-European cultures were incapable of such sophistication on their own, that they required outside help to achieve greatness. This robs them of their rightful legacy and agency. It is far more respectful and far more accurate to recognize these accomplishments as the products of human intellect, acute observation, and immense cultural dedication. The real wonder is not that aliens might have built these structures, but that human beings using stone, bone, and wood, and guided by nothing more than their eyes, their minds, and their deep connection to the sky, achieved such timeless precision. This truth is not less amazing than science fiction. It is more amazing because it is real. It connects us directly to our ancestors, not as passive recipients of alien wisdom, but as active, brilliant participants in the human story. By clearing away these modern myths, we can finally see their achievements for what they truly were, and in doing so, we open ourselves to the genuine and deeply human lessons they have to offer. In the relentless rush of our modern world, where our attention is constantly pulled in a dozen different directions by screens and schedules, the ancient practice of simply watching the sun offers a powerful form of quiet rebellion. It's an invitation to step off the hamster wheel of digital immediacy and reconnect with a rhythm that is far older and more grounding than any notification ping. This isn't about abandoning technology, but about finding a counterbalance, a way to anchor ourselves in the slow, steady pulse of the natural world that continues on, indifferent to our daily anxieties. When you make a conscious effort to notice where the sun rises on your way to work, or to pause for a moment at dusk to watch its descent, you are performing a small act of mindfulness. You are pulling yourself out of the abstract world of data and into the tangible, sensory present, a practice clinically shown to reduce stress and cultivate a greater sense of calm and perspective. This reconnection can be as simple or as involved as you wish to make it. You might start by choosing a window in your home where you can reliably see the sunrise or sunset, making a point to simply stand there for 5 minutes each day, observing the subtle daily shift in the light's angle and color. Over weeks, you will begin to feel the turning of the seasons in your bones, not just as a date on a calendar. For a more profound experience, seek out a local solstice or equinox celebration. These gatherings, whether at a known archaeological site, a public park, or even in someone's backyard, are powerful precisely because of their shared humanity. Standing silently with a group of strangers, all watching the horizon in collective anticipation, you tap into a timeless human tradition. You feel a part of something vast and enduring, a feeling that can powerfully combat the sense of isolation that so often accompanies our digital lives. The most beautiful lesson from these ancient skywatchers is the profound truth that deep knowledge does not always require complex tools. Sometimes, the most revolutionary insights come from the simplest, most patient forms of observation. We live in an era that often equates advancement with complexity, believing that a newer, more complicated gadget is always the solution. Our ancestors remind us that wisdom often lies in stripping things back to their essentials, in learning to read the world directly. A stick in the ground, a distinctive tree on a ridge, the memory of where a shadow falls. These were the technologies that unlocked the cosmos. This idea is incredibly liberating. It means that you don't need a degree in astrophysics or a powerful telescope to have a meaningful relationship with the universe. You just need to be present, to be curious, and to pay attention. By consciously weaving these ancient perspectives into the fabric of our modern lives, we can cultivate a more balanced and meaningful existence. It encourages us to value slowness in a world that worships speed, to appreciate patience in a culture of instant gratification, and to find awe in the ordinary daily miracle of a sunrise. This practice helps us recalibrate, reminding us that we are not separate from nature but an integral part of its magnificent, cyclical story. This personal, experiential connection is the final, essential piece of the puzzle. It ties the grand cultural and historical significance of these alignments directly back to us, to our own lived experience, transforming historical fact into living wisdom. It proves that the silent light of the sun still has much to teach us, if only we take a moment to look up and listen. From the simplest stick casting a shadow on the ground to the most awe-inspiring stone monuments piercing the sky, the story of ancient solar observation is a profound testament to human ingenuity. It's a narrative woven not with threads of advanced technology, but with the far more durable fibers of patience, meticulous observation, and a deep cultural integration of knowledge into the very soul of a community. These achievements reveal something fundamental about us, a universal, timeless drive to comprehend our place within the vast cosmos. Our ancestors didn't see a division between the rational and the spiritual, the scientific and the sacred. For them, measuring the sun's path was as much an act of worship as it was one of survival, a beautiful blend of empiricism and reverence that granted their lives meaning and order. The lessons embedded in these stones and stories feel startlingly urgent today. As we grapple with the monumental challenge of climate change, their example of working in harmony with natural cycles, rather than attempting to dominate them, offers a powerful blueprint for sustainable living. Their long-term, intergenerational perspective building and correcting alignments over centuries stands in stark contrast to our often short-sighted modern cycles, reminding us that true stewardship requires thinking far beyond our own lifetimes. Furthermore, in an age where digital screens can ironically foster a sense of disconnection, their practices invite us to rediscover a tangible relationship with the natural world. They teach us that collaboration, shared purpose, and a collective sense of awe are not antiquated concepts but essential nutrients for the human spirit, capable of grounding us and fostering resilience in a rapidly changing world. This journey into the silent light of the past doesn't have to end when this video does. The very same sky they observed is still right above you, performing its ancient silent dance. We encourage you to step outside tonight or at dawn tomorrow. Find a moment to simply look up, notice where the sun sets along your local horizon, watch how the moonlight changes from night to night. You don't need any special equipment to begin your own relationship with these rhythms. We'd love to hear how this exploration resonates with you. Share your thoughts in the comments below. Have you ever witnessed a solstice event? Does this ancient wisdom inspire you to see your own environment differently? Your insights and stories are what make this community so vibrant. Thank you for joining us on this journey through time and ingenuity. If you enjoyed unraveling this historical mystery with us, please show your support by subscribing to the channel and hitting the notification bell so you don't miss our next adventure into the forgotten corners of our